infinite sheet of current, and it is application for the Ampere's law. So consider an infinite sheet of current. This infinite sheet in the z equal to 0 plane. So in that we have a current density, uniform current density K, that is acting in the y direction. So it is Ky Ay, that is shown in this figure. So we can write this current density, surface current density, as Ky, which is equal to current I by perpendicular distance. And so this current is flowing, that is in the y direction. So when we apply the right hand thumb rule, we can say that this current is acting in the y direction. So the flux lines will be above the sheet and below the sheet in concentric circles. So we can consider a rectangular path, closed path. That is, this dark line shows the flux lines above the sheet, and this dotted line shows the flux lines below the sheet. This is marked as 1, 2, 3, 4, and it is closed path. 1, 2, 3, 1, 2, 3, 4, 1. It's a closed path, and this shows the magnetic flux lines above and below the sheet. Now this length is 2 to 3, that is B. You can take it as B, and this length, that is A. So the surface current density is, we know that is Ky is equal to I by perpendicular distance. So the current is flowing along this direction. So the perpendicular distance to this current is, that is B. So we can write it as I divided by B, that is Ky. Now if we consider this closed path 1, 2, 3, 4, 1, and if we apply the Ampere's law to this rectangular closed path, so this is the Amperian path. This is known as Amperian path. If we apply the Ampere's law to this closed path 1, 2, 3, 4, 1, apply Ampere's law to the closed path, one, 2, 3, 4, 1, we can write that is closed integral h dot dl will be equal to current I, and this is already know that is current I is, we can, from this we can write Ky into B. In terms of current density, we can write it as Ky into B, and this is equation number 1. In order to evaluate this integral, we can consider this sheet is comprising of a number of filaments. So if we consider a small area, that is, in that area this rectangular path is shown like this. This is if it is downward direction, it is minus hz direction, that is in this direction is minus hx, and above that is plus hz, in this direction it is hx. So it is considering a number of filaments, so there may be other rectangular path also will be there. That is also minus hz, this is also minus hx, it is plus hz, and it is plus hx. So when we consider a small area, small sheet of charge, so in that the these two rectangular paths, so this hz direction will be cancel out each other. The nearby filaments, when we consider this hz direction, here it is positive above the direction is hz is shown, so it is positive hz, and here it is downward direction, so it is minus hz. So these two cancel each other. Nearby two filaments, it will be hz will be cancel out each other. So we can say that all the hz component will get cancel out each other. So only remaining is this only hx component. So we can write that h becomes closed integral hx ax if it is above the sheet. So is it greater than 0? Minus hx ax if it is less than 0. It is above the sheet and it is below the sheet. So our plane sheet becomes now so the hx component, that is this will be plus hx and this will be shows the minus hx. Now if we evaluate the closed path, that is closed integral h dot dl becomes, we can say that we split up into 1 to 2, that is again from 2 to 3, then from 3 to 4, then from 4 to 1. This becomes h dot dl. Now from 1 to 2 we know that is h's of a set component, that is 0. Then the distance dl is minus of a, that is from downward direction it is minus of a. Then from 2 to 3 we can say that is minus of hx, direction of h component. Then distance is minus of b, that is in the minus f direction, so it is minus b. From 3 to 4 again it is 0, hz component is 0. Then the perpendicular distance is a, dl is a, plus then 4 to 1 it is hx component, positive hx component, then the distance is b. So this becomes 2 into hx into b. So keep it as equation number 3. Now from equation 1, that is we already written closed integral h dot dl is equal to ky into b. Now we compare equation 1 and equation 3, we can say that ky into b becomes 2hx into b, or we can write hx becomes 1 by 2 ky. So substitute the value of hx in equation 2, substitute hx in equation 2, we will get h is equal to 1 by 2 y ax, 1 by 2 ky ax. This 1 by 2 ky ax becomes, it is above the sheet, that is at greater than 0, and minus 1 by 2 ky ax means it's at less than 0, that is below the sheet. So in general we can say that for infinite sheet of charge, for an infinite sheet of current density k ampere per meter, so h becomes 1 by 2 k cross an. That is, this an represent the unit vector normal to the current sheet to the point of interest.